This video will discuss an inelastic quote-unquote collision where in space we have a spacecraft made of two parts, each with 1,000 kilograms, and in between the two parts there's a spring system that will push the two parts away from each other. Right now the spacecraft is traveling at 600 meters per second. When the spring is triggered, it pushes the part labeled number 1 ahead of part number 2 at a speed of 100 meters per second with respect to this part number 2. So we can use conservation momentum to solve this problem. The net external force is 0 out in deep space, away from any significant gravity situation. The momentum will be conserved. No friction. So momentum before the event takes place, the two parts have a total mass of 2,000 kilograms, 600 meters per second. After the event takes place, part number 2 has 1,000 kilograms with velocity 2. Part number 1 has 1,000 kilograms with velocity 1. We can use the relationship on the velocities. Velocity 1 can be replaced with the expression velocity 2 plus 100 meters per second. So one simplification I'm going to do here is to divide through by 1,000 and then make the substitution. So the 2,000 becomes 2, still have the 600. The 1,000 becomes a 1 times V2, and the 1,000 times V1 becomes 1 times V2 plus 100. That replaced V1. Well, we only have one unknown we can solve, and in doing so we find that V2 has a speed of 550 meters per second. 550 meters per second. And now if we come back to the substitution relationship, V1 is V2, 550, plus 100. So V1 is 650. Let's examine the kinetic energy in this event. The initial kinetic energy, 1/2 mv squared, 3.6 times 10 to the 8th joules. And the final kinetic energy, we have two pieces, 1/2 mv squared for each of them. And when we add them up, we find we have 3.625 times 10 to the 8th. Is that correct? We use conservation momentum to solve this problem. Why didn't the kinetic energies come out to be the same? The spring added energy to the system. So we had potential energy before the spring was triggered. It became kinetic energy. So momentum does not require that kinetic energy be constant. This is somewhat of an example of an inelastic collision, though you might have a conception that inelastic, one object captures another object, but the momentum principle is applied here and successfully shows this event to happen. And the inelastic collision here just means that kinetic energy is not conserved. It was not conserved. Momentum is conserved.